Okay, we are back, and let me start sharing my screen again. And then we're going to get a weird double effect here in the bottom right, but it's okay. Okay, so what I kind of looked at here is I did a couple things during our short break there. I messed with the time step a little bit. I have it on their basic one right now. It's going from 0 to 1 seconds with a step of zero point 0.1 seconds, so it's evaluating it after that much time. I wondered if maybe some of the weird stuff we were seeing had to do with the diffusion coefficient. So I did some quick math using the Stokes-Einstein equation and got this rough number for glucose. It's certainly not a regularized thing. I just assumed that the fluid was similar to saline. I assumed that the glucose had a radius of like 0.5 nanometers, which was a number that I came to after Google searching for 20 seconds. So it's not the most scientific of diffusion coefficients here, but it's just something that I thought might fit a little bit better. It's not that much smaller. It's like 1/3 as big as the basic one they had in there. But anyway, I also changed our arrow surface here to be diffusive flux, so it's actually pointing in the direction where we would expect the solute to go, rather than pointing towards the area of high concentration, which is what it was before. So the arrow makes a little more sense now, but here's what we didn't realize the first time, is that was which time step we were looking at. I think we were looking at the 1 second time step when we were first looking at everything. And let me just show you how this goes here, because we have 10 steps here, so from 0 all the way to 1. And let me just show you how this kind of passes here.
Would go?
Huh?
That arrow at the top, will it like go through the steps?
Yes, I'll go one at a time. I just want to show you what happens here.
Yeah.
Okay, so at 0, I'm actually going to plot it because it's okay. So this is what it looks like at 0. You're like, okay, this makes sense. We have a high concentration at the inlet and lower concentration everywhere else. Everywhere else is like 5, right?
Yeah.
So we're like, okay, this makes sense. Also, I changed the inlet to 10, just
okay.
Just see what would happen. But then we go to 0.1 seconds, and we're like, okay, now we see that there's movement, right? We're getting this movement to the right. Like, okay, that makes some sense. Then the next couple look very, very similar, pretty much no discernible change. And then we get this. Like from 0.4 to 0.5, it basically flips, and I'm not sure why. Yeah, like all of a sudden there's a huge concentration at the right wall that is above 10 apparently. Like it just
So it's
gets
almost as if it all hits that wall and then comes back to the left.
I'm not really sure because like okay, so this makes sense, right? We're at 0. Look at our scale here. Like okay, that works.
And yeah.
Then I go to the next one and it's not so sure anymore. It still looks right, but then we get to the next slide and our scale is 10 and 10, which doesn't mean anything at all. So I don't really know what this is trying to tell us. And then we get to 0.5 seconds, and it has the exact same scale as the one before it, but opposite view.
And does it just keep flipping?
No, after that, it stays on this one for a little bit, and then it flips back. Just randomly. So there's some weird stuff going on here, but I'm really not sure what it is. It's got to be something to do with our outflow, because the inflow seems to be working correctly. Yeah. It's just I don't really see evidence that there's stuff leaving. Like you can't really tell that it's leaving.
Yeah. Could it? I don't know.
Let me actually look at this. I could probably set a manual range or something. Should be 5. Our maximum should be 10.
Yeah. So that's so they're saying it's 10 everywhere at the very end there.
This is the color range. It should be the data range, actually, not the color range. Let me turn that back on. The data range should be a minimum of 5 and a maximum of 10. Right. Okay, let's try, now that I've done that, ooh, we get some weird plotting errors here. That's interesting. Let's see if, can I mess with the quality? No, that was a bad idea. Let's not do that. Uh, okay, I guess we'll just look at that right now and see what happens. Okay, that looks the same. Ooh, that's interesting.
Color just goes away.
Okay, maybe let's try color range again and see what happens. As you can see, when you're dealing with COMSOL, everything has a very scientific approach to it. There's never any messing around. Okay, I don't know what this is. Gosh, okay. Well, let's turn that off again.
And we can see those inner boundary layers aren't affecting anything, right?
No, they're not. They're just lines.
Yeah.
There's no internal boundary, and there's no difference in properties between the layers either.
So Dr. Versypt did say something about the concentration at the very top of the surface, but I don't think that's
Huh.
causing any issues.
Huh. That's interesting. Because we have an initial condition of 5 millimolar everywhere, but then this is concentration at the top surface equals 0.
Because I think what we're saying is once it reaches the edge of the photosite, it just like spreads out, so there really is no concentration, right? Like as soon as you get away from that boundary layer, as soon as it gets
So at the podocytes, the glucose is leaving the system,
yes.
and it's not shouldn't be leaving anywhere else. It should only be entering here.
But it doesn't even look like it's leaving on that plot.
Well, I think it is leaving because if it didn't leave, then after a certain amount of time, we would end up with a higher concentration.
Then 10, yeah.
Yeah, but because there should be a constant entering of the solute, but that doesn't explain why we get that weird flip going on here.
Yeah.
Especially at such a short time distance when the 3 before it don't look any different at all. 3 steps. I don't know. So I guess we could look at let's expand this out. Let's go to like 5 seconds and go every half second or something. We'll just do a fresh compute of it, see what happens. Okay, so at 0 we have the same thing, which we would expect. Make sure it actually is plotting each of these. And then we immediately get this jump.
Yeah.
And at 1 we jump again. At 1.5 it's still the same though. Huh. This is interesting.
Are we just, is it just putting in a set amount?
A set amount of what?
Like the glucose, or is it like for this whole 5 seconds?
No, it should be this inflow. It's a concentration constraint, so it should be a constant
Just
flow
concentration,
in.
right? So it doesn't make sense for it to flip like that.
Yeah, I know.
If anything, it would just like the concentration would get like I don't know.
Let's take a look at the mesh. What does it think? It's a pretty, honestly, small mesh. I'm kind of surprised. Let's try that. Let's get a slightly finer mesh. Maybe that'll do something different. Actually, let's extra fine. Beautiful. All right, let's try again. See if that makes any difference. Sometimes just messing with the mesh a little bit can really change things. So, okay, that looks okay. And we're at half a second. That looks the same. That looks the same. And then we get to flip it 2.
See, but the problem is it's saying like it has this color gradient, but the whole thing is just 10 from what it looks
I know, I know.
So it's almost like I guess it's really not flipping really at all because it's just filling up. I guess this could mean it's just within that time it fills up. Maybe.
It may be. We may be at too much of a time. It's reaching an equilibrium condition, more or less, and then we're just not seeing changes after that because the maximum and minimum, there's just a tiny difference between either side, and so that's where we get that thing.
You want to try doing like 0.1 seconds?
Yeah, let's try that, and I'll do like 0.1 for the step.
0.1?
Did that compute? Sorry, that was very fast. Okay. Next. Okay. Okay. And see, like even here, we're getting to where the difference between the lower and the upper is much smaller.
Yeah. So maybe we need even smaller.
Maybe. Yeah, see here, it's even smaller still.
It probably does move very fast.
Yeah.
We are looking at micrometers, so.
Yeah, you're right. You're right. Okay, 10 to the negative 6. Even that slightly slowed down. It's still on the negative 10 on the. Yeah, we may even want to go even slower. That didn't have any of the weird jumps though. We just ended up getting a different thing there. I think if I set the data range, the manual to 5, then why did it do that? Okay, let's do that, I guess. Then hopefully as it goes, we don't get that big a difference. Yeah, the color range is staying here. So that's actually.
The data's still changing.
Yeah, I think we do need to leave the color range. There. Then if we force it to stay at 5 for the minimum color, then it should, yeah, there we go. Look at that. Yeah, okay, that's better. We just make it where the range for the colors had to stay at the low point. So then we see it progressively increasing in concentration.
There's still a big jump just within 0.1 seconds.
Yeah, I know.
I mean that would make sense. It's like, yeah. Okay, well, that does look better.
Yeah, that looks way better. Do you want to try even slower?
Try it, yeah. 0.05 maybe?
Mm-hmm.
Yeah.
And we could do maybe 0.005 there.
Yeah. I mean, the smaller we make the time constraint, the better it'll look.
Yeah, that looks way better.
I just don't know if that makes sense because we didn't really talk about making it time dependent.
Uh-huh.
Like Dr. Versypt did not explicitly say whether or not to make it constant. Like, what was the other option? It's
Time independent, just static, stationary.
yeah, but it does make more sense for it to be time dependent.
Yeah, it really just depends on what it is that you need to be looking at. Are you trying to see how glucose changes over time
So I think right now
and on how big of a time?
first step, we're gonna start changing things because the more glucose that gets in the system, a lot of other like reactions and other species will enter the system due to that. We're gonna look at that later, but right now I think we're just worried about what we're doing right here.
Okay. Yeah, when you start dealing with reactions, then you probably would want to be thinking in terms of time, because, of course, those reactions are not going to be occurring if there's no glucose for it to react with, right?
Yeah.
So, again, it's just going to depend on what you're looking at. If what you just need to know is the trends, like for my current model is time independent because I have constant velocity of the fluid layer that I'm looking at. So what I need to see is trends of solutes moving through the fluid. So I get I see things like this, even though it's time independent, because the fluid is moving. But for you, if this fluid isn't moving, then it might be more reasonable to think of it in terms of time, because as you can see, like even though there is stuff moving out here, you can see how these arrows are less, even at the high concentration. There is definitely solute leaving at here. It's just coming in fast enough that we still approach an equilibrium situation.
Yeah. Okay. I'm not sure if there's anything else that we need, like that, because I think that's really what Dr. Versypt wanted me to
Mhm.
go over with you is getting the geometry and
Mhm.
boundary condition set up, and then I think yeah, I think that's about all. What else to gather? I think I'm gonna go back and could you save this somewhere that I can get access to?
Yeah, I'm gonna be sharing it to Dr. Ford Versypt, and then she can make it available to the whole group. I think there's probably a good chance she'd put it on our Canvas page. We shall see.
The file. Okay. But I mean, like, I'm assuming you'll save it on Dory, right?
Yeah, yeah, I can save it somewhere where you can get to it. There we go. I'm just naming some stuff so that we can.
So it's clear.
Okay. So, is there anything else about like the general stuff in making the model, like in the adding physics, adding geometry, adding this sort of stuff, adding in results tabs?
I don't think so. I feel pretty comfortable with this. I think everything you showed me today was really helpful as well.
But yeah, okay. For your time dependent stuff, this time step is where you need to, so you can pick your unit, and then this is the range. So it's the start, the step, and then the end point, the range. You could make the mesh even finer if you wanted. We can make it extremely fine. When you're adding in this stuff, like if I wanted to, I could add in another.
Yeah, I had to do this on that tutorial. A lot of those
Mhm.
plots.
Let's see here. What could I put on here? Trying to think of something interesting that I could put on here. Maybe pressure. Probably not. Wouldn't be really relevant here. think the only thing that you can really look at on this model is concentration. So that's where we get this one here. But yeah, I just added this arrow surface. Right click on that. You can add in all this other stuff. I could have made a contour line instead of an arrow. But yeah, it's just took that, went in here and species, fluxes. This is a diffusive flux that's currently being shown with the arrows. But yeah, okay, so yeah, as you'll add in more physics to that, of course, you can do it in the wizard if you want to start from scratch, or you can do it in here. You can add in physics or multi-physics, just add in a whole nother system. In the actual transport of dilute species thing, you can add in more species. And I think somewhere in here you can just straight up tell it to consider reactions. You may have to add more physics for that. I'm not positive on that one.
Yeah.
But yeah,
Um,
that's some of the setup things for this.
yeah. I think I'm gonna keep working on this the next couple of days before I meet with Dr. Versypt.
All right.
If I get to something that's just like I can't figure it out, I might send you a message on Google Hangout
Yeah,
or
for
something.
sure. Okay. You wanna name this anything in particular?
Not necessarily. I don't think we could maybe. I don't know.
Here, I'll just call it Cole's model for now, and I'll leave it in.
Just in the doc.
There's a Cole Strickling
Yeah.
folder there. I'll put it in there.
Okay. Awesome.
All right, there we go. It's free for you to edit as you wish.
Thank you so much. Again, I am so sorry about having to leave.
Yeah, that's totally fine. We just needed to work through some stuff. Hopefully this is a little more workable now, something that you can actually look at and make sense of and do some science.
Yeah.
All right, well, if that's enough for you, I can end the recording and we can sign off.
Yeah. Sounds
All
good.
right. Let me pull up the thing.